You do not have to write this stuff down. This is just kind of where we're going. When you see, what is science? I know you're thinking that it's the stuff you did last year and the year before, which they call the scientific method, right? Like you need to have a problem and come up with a hypothesis and then design an experiment. And that's part of this chapter. We'll go a little further. But I'm mostly going to expect that you know that one, that you know how to identify independent and dependent variables, and that experimental design is something that's fairly familiar to you. That is a scientific method. It's not the science. There's lots of scientific methods. So we'll start today with some of the characteristics that good science has. That if you're looking for something to kind of build good science around, there's 6 characteristics that we see, and that's today. Then experimental design. Then I'll take you through kind of what the real scientists I've known, what their day looks like, what that job looks like, because that's something you've probably never heard. We will also read real science. We will read actual scientific papers that have been published in peer-reviewed scientific journals, and you are going to hate it. It's terrible at first, reading actual scientific papers in actual scientific journals. But it's really good to get a little bit of experience in that now, so that when you're suddenly thrown into it in college, because at some point in most types of degrees in college, you're going to have to read real science, and whew, it can be a slow go. The fun part is what bad science looks like. We'll kind of develop tools for spotting it, because you're just absolutely bombarded with it every day. And then at the end, we'll sort of segue into real biology with sort of a characteristics of life thing. Okay, so that's where we're going. Today is all about what the 6 kind of hallmarks of good science are. And we use a weird acronym to remember them. The acronym is CONPTT, or 2 T's, I guess it's CONPTT. Raise your hand if you've studied CONPTT before ever. Nice. Excellent. Usually there's one. It's not super commonly taught in the lower levels. So let's just kind of go through them. I'll give you examples. First example for the letter C, when I first started teaching, there was a group of scientists, I can't remember if it was MIT or somewhere else, one of the kind of super duper engineering schools. There was a group of scientists that had figured out cold fusion. You know what that is? It'd be like nuclear power without the heat and without the nuclear waste that lasts a bajillion years. It would be kind of the answer to all of our energy problems. And they'd figured it out. Big news on day 1. And then by about day 3 or 4, reports started to trickle in that other people at other universities were trying what they did and were not getting the same results. That is a classic example of consistency. The reason scientific papers are such a pain to read, and I will advise you when I teach you how to read them to skip what's called the materials and methods section. Mostly that section is super long, super boring, and not relevant to you unless you're trying to do what they did, because they have to tell you exactly what they did, right down to the last detail, so that other scientists around the world can repeat their experiments and check, right? So that's what we mean by consistency. We also mean that large sample size is better. That the more, however your experiment looks, the more repetitions. In fact, that's one of the few things that you find in the lingo of both weightlifters and scientists is reps. It's all about reps, right? I was at one point studying the effects of low temperature on bugs, and I was sort of explaining the setup of my experiment to my professor, and he said, "How many reps do you have?" And I said, "Well, 10 groups of 10. That'll do for now until we can collect more," right? More is always better. You always get better, more consistent data from larger sample sizes. So, you know the word observation, meaning taking information in directly from your senses. Of course, our favorite sense is, which one do we rely on the most? Sight. Absolutely, sight. More dependent on sight than anything else. Hearing, I guess, is a close second. Touch. But you don't have to be able to see it, right? And there are things that you can detect by smell. We don't like taste so much in science. You don't want to be going around tasting stuff. But hearing's a good one. In fact, there are sense amplifying devices that use your hearing to communicate when things are there. There's radiation detectors called a Geiger counter. You've probably seen it in the movies where they get close to the radiation source and start to click faster and faster. It's a Geiger counter, right? Using your hearing. What's a classic sense amplifying device that we're going to use in here? Absolutely. Microscopes. Yep. So if we can't observe it somehow, some evidence of its existence we can't observe, we can't call it science. Natural is the N in CONPTT, and by that really we mostly mean as opposed to supernatural. Raise your hand if you have at least a little bit of belief in ghosts or like some sort of kind of spirits, some way that living things stick around maybe after they're dead for a while. Yeah, my hand's halfway up. Like I'm kind of on the fence. There's things I can't explain. Absolutely.
I'm more interested in the concept, but I like to think that ghosts are made of ultraviolet light, which we can't see, but like cats and dogs can.
Oh, fun.
I think when cats get scared by like nothing, they're just seeing ghosts.
Mm-hmm. Yeah, I like thinking about that stuff. There's like a famous ghost right outside my dad's house, the motorcycle ghost in Oxford. That's where my dad lives, where people come and park their cars so they can see the motorcycle ghost, the light going up and down, right? I don't know if that's true or not, but it is true that no example of ghosts or spirits or after images of living things has ever stood up to scientific testing, to rigorous scientific examination. So while it might be true, we can't call it science because at this point it's in the realm of the supernatural, right? Now, is it possible that someday we will be able to reliably detect things like that? Sure. But at that point, it won't be supernatural anymore, right? Because we will have demonstrated that it's a part of the natural world. Predictable, the P in CONPTT is really probably the most powerful thing we expect science to do for us, right? Like scientists have to make predictions. That's kind of their wheelhouse, right? You understand how hurricanes work? Okay, well, where's that one going and how bad is it going to be? You know how gravity works? Well, how come that one planet keeps moving funny? Turns out there's another planet there we didn't see before. We were able to predict its existence just by its gravitational effect on another planet. You understand how the climate works? Well, what's going to happen when it goes up a couple more degrees in average temperature, right? It's all about predictions. We want to know stuff before it happens. We ask science for that every day. Oh, this is a good one. Testable. Can't call it science unless we can test it. Goes a little bit with the N. Natural. I like to use the example of one of my college friends who had a kind of a cool belief system. She commuted to school every day. She had a short, like 10-minute drive to school every day. And she believed firmly that God talked to her every morning through her car stereo. What she would do is get in her car, turn it on, and you know the button that lets you scan through radio stations, like not just to the next one, but it'll keep going through them and stopping on them for like 5 seconds. She'd hit that. And every time it stopped on something, that was God telling her about what her day was going to be like. And she could give you a million examples of, she heard this song and the lyrics were this, and this is what happened to her that day. And then it stopped on a preacher who was talking about this, and man, he was exactly right about what was going to happen to her that day. Give you a ton of examples. Mostly it was music. Is it possible that God's talking to my friend Lee through her car stereo? Yeah, I hope that's how, like, I hope music's kind of how it works. I hope that's like the direct line to God. I like music. Do we have any way of testing whether that's God talking to her? I mean, we could write down the lyrics to all the songs she hears, and then track her throughout her day and see if there's real correlation there. But can we test whether it's God talking to her? We don't really have the equipment for that at this point, right? We don't have the God detector or the direct line or anything like that. It's so what I'm saying is faith and religion and spirituality, perfectly valid way of knowing things, but it's not the same way of knowing things that science is. Does that make sense? The last one's the one that scientists screw up the most. You know the word tentative? Don't make the mistake of confusing it with the word attentive. It does not mean paying attention. What does it actually mean? What's tentative mean? Take at least open to change. You don't have to change, but you're open to the idea, right? If I take a tentative step onto the ice, I'm sensitive to new information. If I hear cracking, I'm going to change my behavior right away, right? You're not completely sure of yourself. And it's a mistake that scientists make a lot, especially, I hate to say it, but older scientists, as their brains kind of get a little less flexible and they start to think that the way they understand things is the way things are. But the problem is that new data is always coming in. It doesn't matter what your discipline is, you're always getting new data. We used to be absolutely sure that the continents on this planet were fixed in place and were where they had always been and always would be. Scientists knew that. And then new data came in. They found fern fossils, right? Fern plant fossils in Antarctica where no fern could possibly grow. They found that the fossils on the western coast of Africa very closely matched only the fossils on the eastern coast of South America. And then somebody, some genius, like cut out pictures of the continents and went, dude, it's like a puzzle, right? And we realized, no, they're not fixed. They move, and they move on plates. And the theory of what was born? Plate tectonics, absolutely. That, yeah, they're on plates, and they do move. And that motion creates a whole bunch of the weird geological phenomena we hadn't understood before, like earthquakes and volcanoes and all that. We used to be absolutely sure that dinosaurs, when they lived, were cold-blooded, slow-moving reptiles. That's what the name means, thunder lizard. Dinosaur means thunder lizard. And then somebody found Archaeopteryx, which was a dinosaur fossil with
Feathers.
yeah, feathers. And more data came in, and everybody said no. They weren't like birds. That's ridiculous. And the more DNA evidence piled up, the more we've learned that, yeah, it turns out that birds are what dinosaurs evolved into. Birds are the surviving line of dinosaurs, which is awesome in a couple ways, right? Like to just look at, hey, you hear the dinosaurs singing? And to think of like velociraptors as like quick moving, warm blooded birds. It's almost scarier to me than lizards.
I've seen art that depicts velociraptors. They kind of have the feathers of Canadian geese, and I just not know.
Yeah.
Goose dinosaurs.
I had fried dinosaur for dinner last night. It's delicious. When we use the word theory in the tentative thing here, it's worth noting that theories in science are much different than they are in our everyday language. We throw that word around a lot. Like, I have a theory. I think you'd do better on tests if you did all your homework. That's not a theory. It's a hypothesis. It might be true. When we say theory in science, we mean it's the explanation that has stood up to everything we could throw, and that we have disproved every possible other explanation. And this was the explanation that was left standing. People get confused and they think that it goes hypothesis, theory, law. Nope. Laws are way different. Laws say that something happens. Theories explain how and why they happen. Theories are basically the endpoints. Once it's a theory, that's the best explanation we've got. Now, it might change if we get new data, but this is our current understanding of how this works. And there's no better idea, no better explanation that we found. And that's about all you can say when you're talking about a complex natural phenomenon. You never know everything about it. Like there's a law that says this. Ready? You aren't ready. I can tell because you jumped. Even on Mondays, that'll work. And the law says it'll happen. But the theory, right? Newton's theory of gravitation explained why. And that in fact it wasn't just the calculator falling to the earth. It was that the calculator and the earth both attract each other because they both have mass. And gravity is a force that means everything with mass attracts everything else with mass. It just looks like the calculator is falling because it depends on how much mass you have, and the earth has way more mass than the calculator, right? And that set of theories of Newton's was terrific, but it didn't explain everything. Eventually, we started to realize, oh crap, there's some times when that theory doesn't work. When we get to the level of really, really tiny things, doesn't work like that. Different things apply at the quantum level, right? Things get real weird. And so we revised Newton's theories into, modern gravitational theory. Einstein's theories, amazing what he came up with. They've been revised and added to, like all theories are. So when you hear the word theory, don't misinterpret it as just some crazy idea that there might be 10 other ideas just as good. There aren't. If we're calling it blah, blah, blah theory, that's the best understanding that science has. That's the best explanation science has for that phenomenon. Good? All right. Well, that's probably good. Let's practice CONPTT a little bit. What I've got for you is a worksheet that kind of goes through each letter of CONPTT in a certain way. All right. This isn't quite as straightforward as it looks, so I want to go through one example with you. In part one, you're going to want to answer a different question than they're asking, and I have to warn you about that. First of all, the first job in each of these is very simple. They give you two statements. You got to circle the one you think is more scientific. That's easy. The second job, where they give you the lines, though, the question you're going to want to answer in there is, why did I pick the one that I did? That's not what you're supposed to answer. Here's the question. For each one, it's going to pick out a different letter of CONPTT and ask how you would use that letter to figure out which one was science. So for letter A, walking under a ladder will cause bad luck is the first option. Green plants will grow towards a light source is the second. You know which one to circle. But then look at the instructions. It says, using the idea of consistency, how can we determine which statement above is a scientific one? That's not asking what you think it is. So you're kind of, here would be my model answer to that question. Okay, using consistency, how do we determine which one's scientific? I would say, well, I'd have a bunch of different people walk under a ladder and then measure in some way how bad their luck was and see if it was consistently bad. And then I'd have to address the second one too. I'd plant a bunch of green plants close to a light source and see if they consistently grew towards it. That would be my answer to that one. So take that and use it for the rest of them, and you won't go wrong. Part two, I'm going to save you some work. The job is to take each of those statements, which are fairly long, through CONPTT and describe how they meet or don't meet each letter, and then decide if they're science or not. I don't want you to have to do that 5 times. I want you to pick out 3 of those and do 3. Okay? Your choice. Take 3 of them through CONPTT. In other words, not just yes, it meets consistency, no, it doesn't meet observability, but how and why it does or doesn't, and then decide whether each of those 3 is or is not science. Yeah. Absolutely. I would recommend that. There's not much space there. Yeah, separate piece of paper is good. Okay? This is homework, is due tomorrow. Yeah. I'll give you the rest of the period to work on it, which isn't a ton of time. Sorry. I talk too much.